Hello everyone and welcome. In here, expect that you'll be solving problems that relates to the topic of linear speed and angular speed. So without further ado, let's now begin. If the radius of a circle is 3 feet, the central angle is 30 degrees, and the arc length is 15 feet, find the linear speed and the angular speed when the length of time taken to form this angle and arc length is 3 seconds. So we have two objectives, find the linear speed and the angular speed. So the formula of the linear speed is S all over T, where your S is your arc length, while your angular speed, it is W is equal to theta all over T. So your theta is your angle. So this one's already easy because all you need is the arc length and the time. So the time here that the time it takes to form the angle and the arc length is 3 seconds. So obviously your t here is 3 seconds. So let's start with here since this one is easy. The arc length is 15 feet all over the time 3 seconds. So your answer here is 5 feet per second. So that is the linear speed achieved. Now for your angular speed, before you proceed, make sure that the angle is in what? Radians. However, the angle is not in radians because it has a degree symbol. So we must convert this one into radians. Remember that if you're going to convert an angle that is in degrees into radians, you're going to multiply that angle into pi all over 180 degrees radians. These two angles are both divisible by 30 degrees. 30 degrees divided by 30 degrees is 1. 180 degrees divided by 30 degrees is 6. So what you have here is 1 times pi all over 6, in which you will have pi all over 6 radians as a result. So with that, we can substitute its equivalent radian in here. So we have pi all over 6 radians all over 3. So exactly your answer is pi all over 18 radians per second. So that is your exact answer. All right. So that's it. It's okay if you want to approximate this one because it's still correct. Right. Usually, usually they consider having exact answer just like this, but in other times they would rather approximate this answer. All right, just like before. Like I think I used to approximate answers when we have a pi something. All right, so yeah, it's up to you. Okay, because it is still correct anyway. All right. So next. The given circle has a radius of 15 meters and a central angle of 35 degrees. If it takes 1 hour to form an arc length of 200 units, what will be... Wait, no, no, no. It's meters, guys. It's meters, not units, meters. Let's go. Then what will be the linear speed and angular speed? Make the time in seconds. So, first and foremost, we need to put all the given. So we have the radius of 15 meters, and we have the arc length of 200 meters. All right. Then we have an angle of 35 degrees. Okay. In this, since we're looking for the angular speed, we must convert this one to radians. Okay. So again, we're converting an angle that is in degrees into radians. You will multiply it by pi all over 180 degrees. So these two, 35 and 180, I think these two are divisible by 5. 35 divided by 5, okay. 180 divided by 5, so 36. All right. So Yes, they are both divisible by 5 degrees. So 35 degrees divided by 5 degrees, it's 7. And 180 divided by 5 degrees is 36. Am I right? Yeah. So with that, wait, let me just fix my solution here. With that, we will have 7 times pi all over 36 radians. So as a result, you have exactly 7 pi all over 36 radians. So we're good. Okay? So that will be your angle in radians, of course. So that's it. So now what's next? Okay? Now you have two choices. Okay? Don't worry, the answer would be the same. It's just that you need to pick which one would you prefer to do so. So first is you must convert this time because according here, it takes 1 hour to form an arc length and a central angle. Get me? Because you see, uh, let's just say this is a part of a circle, right? So let's just say this is 35 degrees, and this one, let me just thicken this part. This one is the arc length, right? So the arc length will form together with the angle. So that means if it takes 1 hour to take then it also takes 1 hour to form this angle. All right. So in 1 hour, uh, the arc length was formed by 200 meters and an angle of 35 degrees. Okay. So now here's the thing. You have two choices. You either convert that time into seconds or convert your answers into a second unit or wait, let me rephrase. First choice, convert the time into seconds. Then second choice, after you get your final answer, convert that hours into seconds. Okay, so you have two choice. For me, I would rather convert it right away. All right, I would rather convert it right away. All right. So 1 hour is equivalent to 60. Wait, no. No, not 60 seconds. 60 minutes. Okay, 60 minutes. Oh, wait. Okay, yeah, 60 minutes. Okay. And in, wait. In 1 minute, it is equivalent to 60 seconds. So that means 60 seconds is just basically 1 minute. So if I have 60 minutes, I will have 3,600 seconds. Okay? Uh, I basically converted. Okay, like 60 minutes. So 1 minute is equivalent to 60 seconds. So since we're looking for the seconds, okay, the minute will be here and the seconds will be on top. Uh, the way how I convert is what you call as a dimensional analysis. It's the same way how I convert kilometers into meters. Do you remember that? Kilometers to meters, meters to millimeters. Do you remember the one we did in the previous problem? So it's just like this. Okay. So minutes are cancelled. So what we have is 60 times 60 seconds. So we have 3,600 seconds. 3,600 seconds. So that's it. So 1 hour is 3,600 seconds. Okay, 3,600 seconds. Let me just write it here. Hold on. Where was it? 3,600 seconds. Okay. So with that, we can now find our answer. So our speed, our linear speed, S all over T, right? So your S is your arc length, so 200 meters all over The time, which is in seconds, is 3,600 seconds. Both of them are actually divisible by 200. Am I right? 3,600 divided by 200. Yeah, yeah. Both of them are divisible by 200. 200 meters divided by 200 is just 1 meter. And 3,600 seconds divided by 200 is just 18 seconds. So we have 1 meter all over 18 seconds. So that means exactly you have 1 all over 18 meter per second. That's the exact answer. But if you wanted to convert it into two decimal places, since this is a linear speed, not an angular speed, so I think this is, wait. Okay, approximately 0.06 meters per second. 0.06 meters per second. Okay, so these two are correct. Now, how about for your angular speed? So the same thing, we can substitute the angle here. So 7 pi all over 36 radians all over your time is 3,600 seconds. So here, this is going to be a very long answer, because if you're going to simplify, this one, you will have exactly 7 pi all over 129,600 seconds. Okay, that is your answer here. Okay, wait, I forgot to put radians. There you go. So I don't know if 129,600 is divisible by 7. Nope, it's not. So exactly, your final answer is 7 pi all over 129,600 radians per second. Okay? You can approximate this one if you like to. All right? So I'll just approximate it, because this one is a very big number for me. So 7 pi all over 129,600. So, oh my God, wait, this is 0.123 4. That's the result. 0.0002 radians per second. Okay, so that's the answer. But both of them are correct. Okay, both of them are. So next, if the radius of a circle is 23 inches, the central angle is 220 degrees, and the time it takes to achieve this angle is 24 minutes, then what will be the linear speed? Okay, what will be the linear speed? Now, you see, linear speed has two formulas. One is this one, the one we usually use, and we have this one. So here, all you need is the arc length. Here, all you need is the radius and the angular speed. Oh, by the way, of course, you need time for this one. However, if you would notice, there is no arc length here. What you have is the radius, the central angle, and the time. So that sucks, because you're not going to use this. But we're going to use this. Here's the question. How would you use that? Okay. What is W? W is the angular speed, right? And you see it is theta all over T. Okay. So that means I can find my angular speed here. Then whatever my results would be, I'm going to substitute it here. Then multiply by the radius. Then I get my linear speed. Okay. So yeah, that's the thing that we're going to do. Okay. So we must find the angular speed so that we can substitute it here. Then We can multiply by the radius to find our linear speed. So here, it's in degrees again. So you have to convert it into radians. So I already mentioned you a lot. I already mentioned about what method you would use just to simplify, just to convert it into radians. These two angles are both divisible by 20 degrees. So 220 degrees divided by 20 degrees, that would be just 11. 180 degrees divided by 20 degrees, that will be just 9. So you have 11 times pi all over 9 radians. So the answer here is 11 pi all over 9 radians. So that's good. So we have our angle as 11 pi all over 9 radians all over the time, which is 24 minutes. 24 minutes. So with that, if we're going to simplify this, we will have 11 pi all over 9 times 24. This would be 216. I'm not sure if 216 is divisible by 11. So no. So we will have 216 radians per minute. So that's it. Okay. Now we can substitute it here. So V is equal to your radius, 23 inches. Let me fix that. 23 inches times your speed here is 11 pi all over 216 radians per minute. So let me just use my calculator. 23 times 11 pi all over 260. Am I right? Okay, good. So this is... Okay, I think I couldn't get the exact answer for this one. Wait a minute. Oh, okay. So exactly, the answer is 253 pi, all over 216 inches per minute. That is your answer. In approximate, this is actually, wait, approximately this is 3.68 inches per minute. 3.68 inches per minute. All right, so that is your answer. Okay, 3.68 inches per minute. If you would notice, I don't usually convert the angular speed into decimal because it is in angle, or it is in radians basically. So I think it's better to leave it that way. Okay, unless it needs to be, to be how to say this, to be in a decimal value or decimal. I mean, it needs to be in a number at least. So okay, there's no problem. But for the linear speed, if ever you have this, you need to. I think much better. You need to make it into a decimal value. If it's in a fraction, it has an irrational number of pi, and so on and so forth. Okay. So, anyways, let's proceed. If the given arc length intercepted by the central angle is 50 miles, and it took 4 minutes to form this arc length, then what will be the what angular speed? Now, here's the thing. You have a formula of angular speed, which is this one, right? But here's the problem. You do have the time, but you do not have the angle here. What you have instead is the arc length of 50 miles and a time of 4 minutes. So how will you find the angular speed? Okay? Wait a minute. Yeah, good question though. Wait. Took 4 minutes. What will be the angular speed? Okay, wait. There's something missing here, actually. Wait, guys. There's something missing here. Sorry, correction. I forgot to put the radius. The radius here, it should be, what do you call this one? This should be 2 miles. There you go. I forgot that. Sorry. The radius is 2 miles. Okay. So going back. Okay, you have the radius, the arc length, and the time. But how will you find the angular speed if you have no angle? So we would use this one. Okay? We would use this formula. Not because we wanted to find the linear speed, but because we can use this formula to find our what? Angular speed. Okay? So first let's find our linear speed. So here our linear speed is what? S all over t, right? S all over t. So here your S is your 50 miles. Okay, all over your time it took 4 minutes. So 50 divided by 4, I mean these two are actually divisible by 2. So 50 divided by 2 is 25 and 4 divided by 2 is 2. So 25 all over 2 is 12.5, okay, miles per minute. Or exactly this is just 25 all over 2. Now that you found your speed, you will substitute it here. And if you're asking me which one though, the decimal form or this one, the fraction form, the answer is the fraction form. Why though? There is a chance that if you're going to approximate that answer, it will not give an accurate answer. Okay? Or let's just say an exact answer. So it's better to substitute it with its fraction form. Okay? Next is we have the radius, which is 2 miles. There you go. Then W. So if we have only one variable that is missing while the rest are given, we can find that one value. Okay? All we need to do is just make it alone. So to find our W, what's that again? We will make it alone, right? So we will divide both sides by 2 miles. So as a result, you have 25 all over what? 4 radians per minute is equal to W. That is your answer. All right? If you're asking me, why did it become radian? Remember that radian is unitless. Okay? So if you're going to divide 25 all over 2 by 2, the miles here are cancelled. What's left is you have minutes, right? You see, it is unitless, but it is an angle that we're looking for, right? Because you see, in the angular speed, we are having an angle as a given. So an angle angle per time. So therefore, the unit here, since the number is an angle, but it is not in degrees, you must represent it as radian. Okay? So we're good to go. So our answer is 25 all over 4 radians per minute. All right? So that is all. So another problem. If the angular speed is 2 pi all over 5 radians per second, and the radius of a circle is 100 kilometers, then what will be its linear speed in meters per second? So here's the thing. We have the angular speed and a radius, and our goal is to find linear speed. So we're not, wait, let me just introduce these two formulas. Which of these two formulas we're going to use? This or this? The answer is this. Why? It has the angular speed and a radius. This one, on the other hand, it has an arc length and time. Although time and arc length are not even given here. So we will use this one. But remember, be careful because we will convert the answer of the linear speed in meters per second. So you have two choice. You have two choice. One, convert this one into meters so that when you get the final answer, it is in meters per second. Or once you get your final answer, you're just going to convert it anyway. So it's up to you. Okay? So let's try to do both, you know? So let's start first by converting 100 kilometers into meters. Remember that 1 kilometer is equivalent to 1,000 meters. So if I'm going to convert 100 kilometers, so I will have this fraction. I'm going to convert kilometers to meters, so I'm going to put kilometers below and meters above. Okay? So cancel out all the kilometers. So what's left is you have 100 times 1,000 meters. So your answer here is 100,000 meters, right? So that is your radius, 100,000 meters. Now, we can now substitute it in here. So remember that your radius is 100,000 meters. Then your angular speed is 2 pi all over 5 radians per second. 100,000 meters and 5 are both divisible by 5. So 100,000 meters divided by 5, this is 50,000 meters. All right, 50,000 meters. Yeah. All right. And wait, no. No, 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 no. This is 20. 20. Sorry, this is 20. Forgive me, 20,000. Okay. So 100,000 meters divided by 5 is 20,000. And 5 divided by 5 is just 1. All right? So that's it. So what's left is so you have this one. Okay? So here, your answer exactly, this would be 40,000 pi meters per second. Exactly. Okay? But as I told you before, we're talking about linear speed, not an angular speed. So I think it's better to approximate this one. Okay? So 40,000 times pi. So this is approximately, wow, it's 125. Let me write it down. 125,661 point, no, 63. Wait, forgive me. Never mind. It's 63. Okay? Wait, 63 point 71 meters per second. Okay, so that's good. That is our answer. Now, how about like, what if we got the answer, then we convert it into meters per second? We can do that. Okay, you substitute it. We have 100 kilometers, right? Times you have 2 pi all over 5 radians per second. 105 are both divisible by 5. So 100 kilometers divided by 5 is 20 kilometers. And 5 divided by 5 is just 1. So what you have here is you will have 20 kilometers times 2 pi radians. No, no, no. Fine. Radians per second. So what you will have here is 40 kilometers per second. Okay? Now we must convert it into meters. Remember that 1 kilometer is equivalent to 1,000 meters. So 40 kilometer per second times, since we're looking for the kilometers, so 1 kilometer is below, then 1,000 meters is above. Oh yeah, I forgot to put the pi here. Wait. It's pi, right? Yeah, pi kilometers per second. And yeah, same thing here. Hold on, let me just fix this up. 40 pi kilometers per second. So cancel the kilometers. So what you will have here is what? 40,000 pi meter per second. See, they're just the same, right? Unfortunately, guys, I think we have to stop right here. All right, don't worry, we will continue this one. Okay, because here, not only we're going to have some more problems about this, but actually involves some real life applications. So stick with me, guys. See you soon.